Hey there, folks. So, last episode, I went through and created our custom data types. This episode, and then the episode before that, and just quickly, our custom data types here. Shouldn't say created them, we moved them into unique files so that we can access them a little easier and not have to clutter up our different classes when they're compiled. However, before that, in episode 22, we actually worked on the consumable item base. Let me just bring up my diagram here. That would be this one here. My oh so lovely green check mark on that one is abysmal. We also covered that we don't actually need a dedicated consumable class. I know in the data type episode I said we would start working on the UI element of things. I actually got ahead of myself. We still need to work on the inventory component, and we're actually going to start on that today. So we are going to get rid of this. We're going to go back to the editor and bring over the content browser. And in here you can see we're in our C++ project files, public, and then we want components. And in here we have a stat line component. We're going to go right click, new C++, C++ class, tongue twister. Scroll down a little bit to actor component, select that. You can see all the file paths and everything are correct. And we're just going to rename it from my actor component to inventory component. We're going to create class. Now, because I am playing in editor, we do need to stop debugging. And just quickly hop back in. We're going to wait for it to prompt to reload, and then we'll stop. And this is taking a little moment here. Well, in the meantime, just while that's going through, there is a few things to cover. With our inventory, there is, as you can see right here, there is a tick component. Now, for most cases, I would say you do not want something like an inventory component to tick. However, I do plan on expanding my item system. I'm actually going to close out a bunch of these tabs because we don't need them. I do want to expand my item system. Actually, I'll bring this up here just quickly. And it's going to be around, let's bring up, what color do I want to use? Let's just use blue. It's going to be around this section here specifically, but I want to add in I'm trying to think the spoilage time. Like how long an item's good for before it goes bad. Like you could have, say, raw meat sitting in your inventory for a little while and then it goes bad. Because again, I'm trying to work on a slightly more detailed survival simulation. So, okay, there's our reload. So I'm just going to cancel the live code. It's off to one side here. Close out of that, hop into the editor, move that out of the way quickly, and close out of the editor. But anyways, as I was saying, I'm looking at expanding this through into a more detailed I can't think of the terminology I want to use here. A survival game that's got some fairly in-depth mechanics with things like food preservation, things rotting and stuff like that. So it's taking a while to close down. We're using, so it was about 3 gigs there when it stopped. Alright, so we'll hit reload because everything else there is done and it stopped debugging. So we have our inventory component here, and this is an actor component that we'll be putting on things like our characters, on storage chests, so on and so forth. And just like before, I'm going to fix a lot of this because it drives me nuts. How there's multiple public declarations in these things. So anyways, so one of the very first things, and it's going to be a key portion when it comes to the game you're working on, is how you want to manage your inventory. So you've got, let me just bring up some oh so wonderful art skills. So you have the various different inventory systems where you have, say, your grid based, where you've got like I think the best example I can think of is Diablo, where you've got no, that's not what I wanted to do. I want selection, CV, where you got your inventory grid. That has its place. That is not what I plan on creating. But you say, yeah, you've got your. I'm just going to do that, and then you have your objects, which are like paintbrush. Like your objects fill up, say, a weird Tetris shape like that. Then you have like your list inventories, which are things like Skyrim. And then you have some hybrid stuff where you've got individual containers that have a list inventory. And the one I'm thinking of specifically with that is Project Zomboid. You have your different inventory containers that each have a max capacity, and that would be things like a bum bag, a backpack, a garbage bag in your hand, things like that. Close out of this, I don't need that. So for myself, I plan on having a, trying to think how to, ultimately I think I just want to go for the list inventory. I'm not too concerned about overall inventory management. So however, I do have some ideas in there that are sort of going to combine certain aspects. But anyway, so going down to the basics. So the first thing you're going to want, I've got cap locks on apparently. New property, edit default only, blueprint read write. Sorry, read only. Meta equals allow private access equals true. And I'm just going to copy that because we're probably going to use this a bit. So you're going to want a float value. And the reason I'm specifying a float, not an int, and I'm just going to bring this up, is in our item base, our weight is a float. And to save casting issues of like you've got a 1.25 and we're casting it into an inventory that's say using an int where that 0.25 could be lost, you want to keep the same accuracy in your numeric value. So max container weight actually no, we'll say max weight because it's not always going to be a container. So we're going to say max weight, and we're just going to start off with 100. Don't need the .f. Now we don't want an edit default only for this one. It's going to be visible anywhere. We're going to have a float current weight equals 0. And this is quite literally, this is how much it can hold and how much it is holding. And then now we need a way to identify the contents. Using edit default only allows you to like preload certain containers with inventory if you want, as a blueprint. So you could have like a preloaded, excuse me, my chair is squeaking, a preloaded crate with medical supplies, things like that. So now this is where it gets a little complicated. So you could have don't need the arrow there yet. T-array class U item base contents. However, it's not going to work because this needs to be T sub class of class U item base. And this is going to be that array of your items. However, that comes down to, we have max stack size. And I actually need to make a correction to what I said in one of my previous videos. Because in the previous video I said we're not worried about the max stack size and the current stack size in our item base. I was wrong. We do actually want to include that here. I did some further planning between episodes and I realized we do need a current stack size as well. So I'm just going to copy that entire set there and change this to current stack size. And doing that, we do need to also add in int get current stack. It's going to be a const. We're going to return current stack size. And we're going to need to add some extra functions in here. So we're going to go U function, blueprint callable, bool add to stack const int reference amount. Actually, no, we want to do this as an int. And then we want to do pretty much the same thing actually, and I'll explain why we're using an int in a moment, except from instead of add to stack, we want to remove from stack. So we're going to create these definitions. I always do that go to instead of quick action create. So if current stack size equal to max stack size, we want to return amount. So what this is, what we're doing here is basically we're saying, okay, we want to add, say, 5 items to the stack. There's only space for 3. That's what this int is for. It's how many are remaining after we've added. But in this case, so if our current stack size already is the same as our max stack size, we can't add to it. So we're going to return else. No, we don't need an else there. We're going to have to use a local storage variable. Int used equals 0. So no, we don't want to use that. We want that remains. So we want remains equals max stack size. So I'm going to use some numbers here in a second just to explain that. And I'll do that in the comment above. Now, how did I want to do this again? So it was, oh, right, math. What is just an int math? Int. Floor. That was it. Remains equals floor. No, it's a clamp. My brain is not wanting to work today. It's been insanely hot and my brain is shut off. Okay, so UE5 C++ int clamp. put one too many pluses there. Clamp integer. Why am I not working this one out? That's blue. Oh. Is it really fmath clamp? Oh, it is. I'm using fmath, reading fmath as float math, not Unreal Math. Okay. Fmath clamp, and that returns. So we want amount minus max stack minus current stack, and the max will be amount, and amount equal, oh no, remains equals. So just for the purpose of the maths here, we're going to say, let me add a comment so I can do this without causing errors. Amount is 10, max stack size is 5, current stack size is 2. So what this is going to be is, that tells us we have 3 left. Well, we have space for 3. So we're going to deduct that from the amount to get the remaining. And that's going to give us a value between 0 and current. So if for whatever reason this fails, it shouldn't, we can still get a result of 0. And then we want to current stack size plus equals amount minus remains, return remains. Now this is very janky, and I'm going to think of a better way to do this. However, this is a very basic setup just to increase the stack size. And then we want a similar functionality for removing from the stack size. We want to be able to say, I want to take off 1. So if current stack size is less than the amount, we want to int removed equals current stack size, and then we want current stack size minus equals amount. Oh, sorry, no, this one would be equals 0, return removed. So again, we'll use that same math. If this is 10 and our current stack size is 2, we're only able to remove 2. So that's going to say removed is 2. We set our stack size to 0, and then we're returning the 2 we removed. No, sorry, we want to return the remaining. So that's amount minus removed. Else we want to, like, so that's, just to be clear, this is, we're returning how many we still need to remove. Or do we want to? Now, this is one of those, it's going to be down to how you personally want to work the logic. I'm actually rethinking that. I want to say how many we actually consumed, so I want to return removed. So if we've only been able to remove 2 out of the stack, then we want to say we only removed 2. And otherwise it's current stack size minus equals amount, return 0. So now there is one other thing we're going to want to do here. I will cover that in a moment, but so the reason for this, and adding these two functions in. And just because they are a little more complex, I added them to the source instead of in the header. But the reason for that is how we're going to be storing them. It's literally just going to be a T array where we just stick things in. And there's a reason for that. Is part of my inventory system, it's going to include drag and drop. If the player just puts it in their bag, it's going to go to the top, or for those who understand T arrays a little better, it's going to be at index 0. I know it's a little inefficient at code level, but and the reason being is, so the first item they put in their backpack, if they just keep throwing things on top and not organizing it, that very first item they put in is always going to be at the very bottom of the list. So it's sort of to indicate what items are closer to the top of the backpack versus what are towards the bottom. So, and on that note, we do need to add some functions to that. So, U function blueprint callable bool add item to stack. No, add item to top. And then we need class U item base const U item base. Yeah, reference item. And then we need another one, U function. I just copied that. Why am I doing that? Bool add item at index const class U item base item int constant reference index. I'm going to use IDX. And then one final one, bool add item to stack at index. Now these are probably not going to make any sense right now. I will explain them as we go. I'm going to be working on these slowly for the next couple of episodes, I think. Int reference IDX. So, first one, it's going to be very very simple. Add item to top. So if current weight less than or equal to, current weight plus item dot. Oh, I need to include item base. It's an undefined class. Or unknown class otherwise. If current plus item dot weight get stack weight. Yep, that's the one we want. Get. And we need to add that other function in there actually, because we got get stack weight, get current stack. We don't need that actually. Return item weight times current stack. That's what we called it. Yeah, current stack size. Item dot get stack weight. If current weight was greater than max or weeks max weight. Return false. And down here it's return true. And the true and false literally just indicates did we successfully add it or not. And then, what do we call this? Contents. Let's call it inventory contents, actually. Inventory contents. think it's because we're using const references. Get rid of those. So functions declared. No instance or load. That's what it should be, though. Oh no, it's because I have this. My own brain is not functioning. T subclass of. Apparently I'm hitting keys I shouldn't be. Class. I've done this before and I'm trying to remember how we do it. Oh, capital I, that's why it's not working. Item dot. Sorry for sitting here in silence. I'm just trying to. Oh, there we go. That's just because I hadn't closed it off. Dot insert item at 0. There we go. So what we're doing with this one, and again, I apologize for that silence there. My brain was firing, but my mouth wasn't. So just going through, because we're just doing a subclass of, we need to use the get default object. And what that's going to do is it's going to do some casting for you to get the item or the original class. And then we can call get stack weight on that. From there, we can say, okay, oh, I missed. So that's greater than max weight. I removed that one. I shouldn't. So our check here is if the current weight plus the item we're trying to add's weight is more than our carry capacity, we're going to return false. And if it's not, we're going to add it to our contents. And then what we need to do is current weight plus equals that. And actually, because we're going to do casting item weight, I'm going to do this once here because I don't want to do this twice. So just again to run through these. So we have, we're quickly grabbing the stack weight of the item we're trying to add. We're doing comparison. If that would put us overweight, we're going to return false. Now some inventories let you go over capacity and you slow down. I'm thinking about that. That's a design decision I haven't been able to nail down yet. And this goes back to what I mentioned in the intermission. Not everything is going to be 100% nailed down as soon as you get past the proof of concept phase. The inventory system itself, I'm still up in the air about. That's sort of why it took me until episode 20 to get started on it. But anyways, from that, In my case, currently, I am not allowing you to go overweight. Um, I may do that, but there'd be a lot of cross-referencing um, classes that I'm not sure I want to do yet. And by that, I mean your inventory is going to have to talk to your stat line and back and forth. So, but anyway, so with that, as long as we have the weight capacity, we're sticking in our inventory and we're updating our current weight. Just so we can get this to build, I'm going to quickly define these. And we're going to run a quick build on this, just to make sure we have no build errors. And as long as this works, which it didn't, 26 protected. Oh, I'm missing a semicolon. Let's try that again. That failed. Found on 37. Oh, that's because let's fix these. Okay, we'll try that one more time. 137. Oh, I deleted the name. Wow. So this is another bit of advice I will give to everyone. If you're mentally not, I want to say sound, like this episode really proves, and I know most people would probably just ditch the episode, but if you're having an off day, don't be afraid to. Now, I'm not saying this in case you're actually working for a company. It's not the same. If you're working on a personal project like this, don't be afraid to just say to yourself, I'm in no state to be working on this right now. Wow, what is... Because clearly I'm really not in the state to be working on this. My brain is fried from the heat. It's a little late in the day for me, so... But anyways, so, point of that being, if your brain's not in it, don't force yourself to work on it. You are going to make an untold number of stupid mistakes. And you're going to end up, just like I'm probably going to end up coming back and looking at all of this work and going, why did I do this? But, anyways, oh, the build's finished. There we go. It has completed. Now, we're not at a point where we're ready to throw this onto a character yet or get any further than that. We still have a couple other items to expand upon. However, we have hit that 35-minute mark. Actually, no, this episode I'm going to let go over. I want to finish these off. Monkeys to that 30-minute recommendation that YouTube tells me to use. Anyway, so let's finish up at least these two functions. So... add item at index. Well, we already have right here, we have our logic. Now, I've just done something that, on purpose, that I hope nobody does. The second you copy and paste a chunk of code like this, create a helper function. In this case, I'm just going to do it here as a private function, bool over carry weight. No. Is over carry weight. And pass that in, call it item. So we have this here. Well, actually, this is where I'm going to question myself on that, because we need to, like, it's this portion of code that we're reusing. Yeah, we're still copying and pasting. So And we can change that to a float, actually. It doesn't need to be the item reference. So actually makes this a little cleaner. So we can just do a const float reference item weight. Save that. So return true. And actually I'm going to make this a const and make it accessible to U function blueprint. Callable. So what we're going to be doing here is if and the reason being for this is it just saves, I can't even spell weight properly. Let's go back to our header. The reason for this is, as I mentioned, like if you want to have that potential to go over your carry capacity and it'll slow you down, doing this allows you to have some logic in there. It's like, okay, you can go up to twice your carry capacity before it denies. Okay, it's not doing that. So doing it this way, what that's going to allow us to do is when I change my mind, if I change my mind, it's going to allow me to only have to adjust this logic here instead of all of the logic in every single function. So let's do that. So add item at index. So that's if you want to put it in like the 4th slot. So it's pretty much the exact same thing, except we're going to add IDX to reference the index we're saying we want to add it to. However, and actually we don't want to make this a const because we want to be able to adjust this. Where are you? Add item to index. Just in case we have a math error somewhere. So if IDX is greater than or equal to inventory contents dot num. So now to explain this, inventory contents dot num uses a human counting system. It starts at 1 and goes up. Well, actually, sorry, it starts at 0 and goes up. If there's nothing in there. So if the index is, no, we want it to be greater than. No, I'm trying to think. If there's nothing in there, it's going to go to index 0. Okay, let me just bring up something here to help. And this is something else, again, don't be afraid to do. Bring up whatever you want, be it a piece of paper. I normally have a notepad I do this on, but again, it doesn't work when I'm trying to record a video. So you're going to have index 0, 1, 2. I can't write with a mouse. 2, 3, 4, and so on. So index 0, if that's, we're coming in saying we want to assign it to index 1. I'm just trying to think. So if we don't have any items, if it's greater than, if you have one item, the num is going to be 1. And index 1. Yeah. Okay. Sorry, I just needed to do the mental thing there. So what we want here, if the index is greater than the number of items, so we have one item, but it comes in, we want to put it at index 2. Well, that's not going to work. Let me bring this back. So index 0 is going to be our first item. Index 1 would be where we're wanting to put it. Index 2 doesn't exist. it's null. That's outside the array. So yeah. ID x equals inventory.num. And does that create? No, actually, insert a given element with array at a given location. Index tells where it ends. This might actually throw an error. Well, either way. So now this one here. No, say either way. I will obviously, when we get to debugging, I'll be stepping through that. For some reason, I'm thinking if we're at the end of the index, we need to expand. But we'll cover that when we hit to that episode. We'll get to that episode. I'm not 100% on the Unreal Engine's T arrays. So add item to stack at index. This one's a little different because we're not just throwing it into the array. We're trying to update an existing. So we want you. Actually, don't need these classes in here because we have the header included. So we have u item base pointer target item equals cast u item base inventory contents at idx int remain equals target item dot add to stack item dot get default object stack get current stack. If remain greater than 0, or actually we need to add this in here first. So remain greater than 0. Actually, I'm going to fix this in a second. I just thought something else. Actually, did we add a set stack size to this? Add stack? Nope, we need to add a set stack as well. Void set stack size const int amount. This one there's there's no logic, so it's just current, and we'll put it in the header. Current stack size equals amount. All right, so item dot get default object set stack size remain inventory contents dot push. There's a pop. That's removed from the front. Yeah. So push. No, that's add with these. Add item. Now, one thing we can do here is with this, we have already added this amount of weight. So we can just simply at the very end before we return, add that in, return true. So just to explain, because my brain, you may have heard me mention it before, rubber duck debugging. Sometimes explaining things will fix what you're wanting to do or help you understand it and identify a problem. So in here, just like with the past two examples, we're grabbing the stack weight of the items we're trying to add. We're checking if it is over our carry capacity. If it is, we're just saying we can't add it. This is where you would potentially add in partial stack logic. I will be adding that in at some point in the future. However, right now, the focus, as it should be with all these projects, because we're still in not the proof of concept, but the pre-alpha, very early stages of actual development. We're just trying to get the basics in and working. So if we're not overweight and we can add it, we're going to get a pointer to the index. Now we need to add some validation like up here. So if the index is greater than or equal to, in this case, I'll bring back my little paint diagram here. So we have 2 items in the, oh well, doesn't let you change size there. I'm too used to things like Krita. Anyway, so you have 2, come on, select. You have 2 items in your array. You've got them at item 1 and item 2. And you're coming in, so that's index 0 and 1, and you say I want to add it to index 2. Well, there's nothing in index 2 to add to. So what's going to happen with, let me just find that here. I pulled something up there apparently. Oh, I haven't finished my if statement, that's why. So index 0 and index 1 are going to be our 2 items. If we come into index 2, this is going to fail because that's going to be a 2. Well, there's nothing in there. So we want it to, but this is going to return 2 because there's 2 items in there. So we're just going to put a catch-all return false. And I'm going to do add error logging. So this is a catch-all in case we're index out of range. Yeah, you may have seen that in a lot of games. I see it coming up quite a bit because they don't always catch themselves. I don't want to say they don't understand that some of these things start at 0 or other things start at 1. Index of operators are always a pain, the short of it. But anyway, so this is going to get us a reference to the current inventory item. We're going to get the remaining, how many we can add to that stack. If we can add the full item, remain is going to be 0. Otherwise, we have something left. So we need to put a second stack in there. I know we don't want to add because that's going to put it to the bottom. We want to put this on the top, so it's going to be insert item 0. And then we're going to adjust our weight, and we're going to say we added it. I'm just thinking if the index is greater than, yeah, no, that is what we want there. I was thinking we wanted to change something here. But no, that's correct. And that's correct there. So we're going to do one final build. Hopefully I didn't break anything here. And as long as all of this builds, I will be ending the episode. And hopefully that is it. But for now, though, because this looks like it's going to take a moment because it's going to have to rebuild all of the item files as well. I'm going to pause things here quickly, and I will be back as soon as this build's finished. And I say that, and the build immediately finished. So it's one of those things, I swear. But as you can see, this build did go through successfully. Now, I do personally have some concerns, potentially broken. And what I mean by potentially broken there is this might not actually work. My concern is it doesn't dynamically expand the array. Actually, let's just check on that. UE5, I'll bring this over in a second. T array insert. All right, let's bring this over so we can actually read this. T array. And place. T arrays most common container used in the engine. It's like a list or a vector, very similar to. I won't say identical, but very similar to a list or a vector. Add in place, puts them at the end of the array. Yeah. Add unique ensures there's only one. We don't want that. Append adds multiple elements at once. Insert, like add in place, and append adds a single element or a copy of an array element at a given index. That doesn't. So where my concern is this particular function, insert, does not expand the array. Well, let's do a quick check and see. Didn't want to turn this into a C++. Get data plus index, element type index. Construct a copy in place at index. This new operator will insert an index. Okay, so no, it does. Exactly what I was concerned it wasn't doing. So with that then, folks, I'm actually going to close out of this. Don't want to leave it open. With that though, folks, I am going to end the episode here. I know this episode didn't really get much done or appear to get much done in the way of the inventory system. However, it does cover a lot of the core functionality that we need to use. And after that, next episode, we are going to be able to start expanding things a bit. We'll tie it into our harvest actor pickup and our logs that we've got. And we should be able to start at least pushing things into the player inventory. If not in the next episode, it will definitely be the one after that. So, as always though, thank you for watching. Any comments, questions, concerns, suggestions, please feel free to throw them in the comments below. Thanks again, and I will see you in the next episode.